All right. I want you to write this up here. Okay. If lines are parallel, then angles are, and you have a blank. So this is what we've been doing up to now. We started with parallel lines, and parallel lines created certain types of angles. So, okay, if the lines are parallel, then the angles are whatever their relationship is. Okay, so our warm-up was a lot like that. Now, we need to be able to go backwards. And going backwards is called the converse. Kind of like reverse, right? But they call it converse. So, if angles are blank, we would have to state their relationship. Then lines are parallel. So this second one right here, do you see how I just flip-flopped my thinking? That's all I did. I just flip-flopped it. That's what we're mostly doing today. We have to analyze this, right, based on what we know. We also have to analyze this. It kind of depends on the question you're given, okay? So what is well, converse is basically the opposite of something, like going backwards. So let's talk about these two words here. Postulate. Okay, a postulate is a truth or a fact no proof needed. I don't have to prove it to you. Okay, so here's an example. If the sun is up, then it is daytime. That is absolutely a fact, and nobody has to prove that fact. Okay? So if blank, then blank. Everybody see that? So if then is really important in geometry. That's kind of how you start your sentences. All right, so here's another one. If the lines are parallel, then the angles are, and we would state their relationship. We still have an if then. Okay. Now, the converse of that is where we just flip that. We just flip it. So, the sun is up, then it is daytime. Okay? If the lines are parallel, then the angles are whatever their relationship is. So the converse is the flip-flop of that. Okay? The if-then statements are swapped, and it is the opposite of the postulate, and it is still true. And it is still true. And I'm going to give you an example of when you use a converse and it's not true. Okay, so if it is daytime, if it's daytime, then the sun is up. Okay, so all I did was I just flip-flopped this. So here, sun is up. Now the sun is up is the second part of my statement. Do you see how I flip-flopped it? If the angles are blank, 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 whatever they are, then the lines are parallel. Then I just flip-flopped it. me give you an example of a converse that's not true. Okay, so let's say this is the postulate. The postulate is, if I live in Idaho Falls, then I live in Idaho. Is that true? Yeah. So if I live in Idaho Falls, then I live in Idaho. That's the statement. Okay, let's write the word converse. So now I'm going to show you what happens when you reverse it and you don't check that it's true. Okay? If I live in Idaho, then I live in Idaho Falls. So all I did was I took the ending and I put it first. Is this a true statement? Why? What? Because it's not always true. Where else could we live in Idaho? We could live in all kinds of places. Pocatello, Blackfoot, Boise, Sandpoint, Coeur d'Alene, like, right? So that is not always true. So you have to double check. When you flip it, does it still hold true? And if it doesn't, then there's a problem. Okay? All right. So we're going to flip our page. We're going to go to page 8. Everything that I highlight is the answer to a question. Okay? So if I give you like a sentence stem and it's fill in the blank, then you fill in the blank with the correct vocab. Okay? All right. So let's take a look here. Let's do this angle here and that angle there. Okay, I have one arc and two arcs because obviously they're not the same measurement, right? Okay, these are consecutive interior angles postulate. In other words, same side. That right there is actually an answer that you would write on a blank. And what it means is, and we've been talking about it for days, if two lines are cut by if two parallel lines are cut by a transversal, so the parallel lines, then the pairs of same side interior angles are supplementary. Okay? Because we know that these add to 180. We know that. Okay, so let's say I ask you what these are, and you say, they're consecutive interior. Great. What do you know about them? They add to 180. Great. Why? Okay? Because the lines are parallel and create consecutive interior angles. This postulate would be the answer. Okay? So here we're going from parallel lines to angle relationship. That's what's happening there. But if the converse, okay, so this is important, and a lot of students will leave that off. They will leave off converse. You can't leave that off, right? So there's a lot of vocab in this unit. So the converse of same side or consecutive interior angle postulates states that, okay, If two lines are cut by a transversal so that a pair of same side interior angles are supplementary, then the lines are parallel. So I just flip-flopped it. That's the converse of that. So sometimes your answer is this one, consecutive interior angles postulate, and other times it is converse of that. All right, so I'm going to go a little faster, but I just kind of wanted to go over that. Oh, and by the way, the converse is where we go from angles to parallel lines. That's the difference overall. All right, so next we have alternate interior angles theorem. Now, this one has to be proven, and we'll get to proofs later. Okay? But alternate interior angles, so you have one here and you have one there, right? So this one means I'm going from lines to angles. So if two parallel lines, right here, two parallel lines, then alternate interior angles have the same measure. They're congruent. The converse of that, and we can't leave that word off, okay? If two lines are cut by transversals so that any pair of alternate interior angles are congruent, then the lines are parallel. So we're going from angles to parallel lines. Okay, and then, by the way, I don't have any numbers on here, but do you remember when we did this and we put all the numbers in and we showed that there's only two numbers? All the acute angles were the same and all the obtuse angles were the same. Okay? So that kind of comes into play. All right, alternate exterior angles. So let's do this one and this one. Okay, so you got two parallel lines. So if the lines are parallel, then alternate exterior angles have the same measure. They're congruent. And again with the converse, okay, if any pair of alternate exterior angles are congruent, then the lines are parallel. Okay, and our last one, corresponding angles theorem. So there's a corresponding angle with that one. Okay. All right, two parallel lines. So if my lines are parallel, they're cut by a transversal, then pairs of corresponding angles have the same measure. And then the flip of that, the converse, right? If any two lines are cut by a transversal so that any pair of corresponding angles are congruent, then the lines are parallel. So you have to write your answer a very particular way. Very particular way. Your answers are these that I'm putting stars by. Okay, I'm glad that you're able to pick out characteristics such as acute and obtuse and supplementary and complementary and all of the things. Okay, but this right here, that vocab is your answer. It's more like a vocabulary phrase, right? So, identify the type of angle pair described by the given condition. How do you know that line L and M are parallel? So what we're having to prove is why. Why are those lines parallel? There's no symbol on there that tells me they are. So why are they parallel? Okay, this says that angle 3 plus angle 6 equals 180. So look over here. We've got angle 6 and angle 3, and it says those equal 180. So why do they equal 180? One's obtuse and one's acute. Yes. Why is that so? What would we call these angles? Consecutive interior. Or you could say same side interior. I don't care which you use, right? So the reason, this is your reason, ready? Converse of, and then you can write your consecutive interior angles. You can't leave off the interior and you can't leave off the converse. Okay? You cannot leave those off. That is part of your answer. Okay. Now let's take a look at 2 and 6. So 2 is right here. And this statement says that 2 is congruent to 6. All right. Well, what kind of angles are those? All right. They're corresponding angles. All right. They're corresponding angles. So to prove that the lines are parallel, I have to write converse of corresponding angles. And I cannot leave off converse. The reason why I cannot leave converse off is because I'm using the angles to prove that the lines are parallel. Normally, we know the lines are parallel and we use that to prove the angle relationship. Okay? All right. So now, we're going to put this into action. You are going to practice this with me. Okay? Everybody got a pencil? Yeah? Or a pen, whatever you're writing in. Okay. We have a 50-degree angle and a 30-degree angle. One is acute, one is obtuse. What else do we know about those? They are consecutive what? Consecutive interior. Meaning, what do these numbers have to do? Okay, do these add to 180? So these add to 180. I can write myself a little note there. So, converse of, oh, I cannot spell today, consecutive, okay, I'm just going to start over. Consecutive interior angles. Now, I'm not writing the word theorem, okay, you can leave that word off, but I cannot leave off the converse and I cannot leave off interior. Well, actually, I can't leave any of that off, but those two words in particular. Okay, let's go look at this one. You have a 70 degree and a 70 degree. What kind of angles are those? They're corresponding. Corresponding angles are congruent. So, because our corresponding angles are congruent, the lines are what? Parallel. And what's the reason? Come on, guys. Converse of what kind of angles? Corresponding angles. All right. Oh, look. Kind of like our warm-up. You see that right there? You have a 75 and a 115. Okay. So if this was a quiz or a test question, if I were to do this, okay, these do not have a direct relationship as shown on this page right here. Do you see that? It doesn't fall over here. However, I do know that this angle is 75 degrees. Why? Why is that angle 75 degrees? What are these? Huh? Yeah, they're vertical. Okay, vertical angles. They meet, their vertexes meet. Okay. Because I know that's 75. What do I have to test about these? They look like they're what? What do they look like? What kind of angles do they look like? Vocab, what do they look like? Okay, consecutive interior. That's what they look like, right? So if they're consecutive interior, what do they have to do? Add to 180. Okay, so our job is to figure out if they add to 180. Well, what do you think? 75 plus 115. Do they add to 180? Is that true? No, it is not. In fact, what is it? It's 190, right? They don't add to 180. So that means that line P is not parallel to line Q. That's what that means. The converse doesn't hold true. The 75s are absolutely true, but because these two don't add to 180, the lines are just intersecting. They're not parallel. Okay? What kind of angles are these? Okay. So these are alternate exterior, and what do we know about alternate exterior angles? What's our word? They are congruent. If you speak the vocabulary words, they stop being weird and they become part of your vernacular. Okay? So they're congruent. Now, because they're congruent, the lines are parallel. So we would say converse of alternate interior angles. Okay. Number 7. See these two arcs? And these two arcs, what does that tell you about these angles? What does that mean? They're congruent. I have two arcs here and two arcs here. They're congruent. Now, why are they congruent? They are congruent. Why are they congruent? Because they're vertical. Okay? Okay. So,
why was number 6 the converse of alternate interior angles?
oh, because I wrote it wrong.
Okay. I like it.
Wow. Thank you. I need more coffee. Guys, you need to speak up if I make a mistake like that. Okay? And that is a common error, by the way. Okay, I even wrote alternate exterior right here, and then I turned around and I wrote interior right there. So that's something to watch for. Okay. Vertical. Yeah? Okay. So let's put an X right here. And actually, I want to add something to this picture. I'm going to put a Y right there. Draw two arcs and put a Y right there. I'm not sure why that was left off, but we're going to add it. Okay, the two arcs tell you that things are congruent, right? Yeah? These right here. Vertical angles won't tell you if lines are parallel. You can make it warmer. Vertical lines do not tell you if things are parallel. There's no way to tell. Just like up here, These were not parallel, and those are vertical angles. But here, okay, what are these? What are x and y to each other? They are congruent. If x is congruent to y, what kind of angles would they be? Yeah, they're alternate interior. X and y are alternate interior, right? Okay. You could say, then P is parallel to Q. That would be your statement, and here would be your reason. Converse of alternate interior angles, and those are interior. Do you notice how our answers are not numerical answers? They're not one-word answers. They're sentences and they're phrases. So those are the kind of answers that you're going to have to provide. They're not numerical answers. Okay, what kind of angles are these? Corresponding. These lines right here mean that they are what? They're congruent, right? So are the lines parallel? Yeah. So P is parallel to Q. This is like an official answer. You would say P is parallel to Q by, and then you would write converse. Thank you. Of corresponding angles. Okay, so on these up here, 3 and 4, I should have started with right here, and 6. 3, 4, and 6, I should have started with that. Okay, now we're going to get to the math part. It says find the value of x that makes P parallel to Q. So now we're going to force the issue. What kind of angles are these? They're corresponding. Corresponding angles are congruent. So, for the lines to be parallel, those have to be congruent angles. So I'm going to write down 3x equals 45, and I'm going to go figure out what x is. So I'm dividing by 3, and I get x is 15. That's not 15 degrees, that's just 15. Okay, so here's our official answer. Ready? You have to do all that, and then your official answer is if x is equal to 15, then P is parallel to Q by the converse of corresponding angles. Look at that long sentence of an answer. That right here is the answer. So if blank, then blank by blank.
Can you
Okay.
explain why you say converse again?
Because I'm using the angles to prove that the lines are parallel.
Okay.
So the word converse means that you are using your angles to prove parallel lines. If you are using parallel lines to prove the angles, then it's not the converse. It's just the theorem or the postulate. Okay. 10. Let's do 10. What kind of angles are these? They're corresponding, which means what? They're congruent. So what are we going to write down? 2x plus 10 equals 120. Okay, so there's our math. Now what are we going to do? Okay, let's subtract 10. We end up with 2x equals 110. What do you do now?
Take off our 2.
And what do you get?
55.
Okay. So we did a little bit of algebra based on an assumption. Okay. They're corresponding. They are corresponding. Corresponding are congruent. So here's our official answer. If x equals 55, then P is parallel to Q by what converse? Yeah. Converse of corresponding angles. That's my official geometry answer. Isn't it lovely? Okay, now we have one last one, and then I'm going to have you guys do some practice. Okay. 80, and then 2x plus 20. First of all, I like to look where they're sitting. So what angles do those look like? Okay, so they look like alternate interior. And what do we know about alternate interior angles? Alternate interior angles. Alternate interior angles are congruent. Okay, and if you're not sure, look at it. This is an acute angle, and this looks like it's acute as well. Okay, all right, so we have to set 80 equal to 2x plus 20. What's our first step? We're going to subtract 20, and we get 60 is equal to 2x. Then what do? We divide by 2. Okay, so x is equal to what number?
30.
30. So our official answer is, if x is equal to 30, then P is parallel to Q by what? Converse of what? Speak louder, please. Thanks. Alternate interior angles. So that's my official geometry answer for that one. So you might have to do a little bit of math. Okay? But this is your official answer, and this is what I'm looking for. So either today or tomorrow, when you get your little knowledge check, you definitely want to have these notes out front and center so that you can refer to them. What's my vocab? What should my answer look like? How can I mimic that? Okay? All right, so you picked up a worksheet, correct? Let's take a look at it and just see. Let's just see if anybody has anything they need me to clarify before I turn you loose and have you work. In other words, does everything make sense on the page? Can you read the words and you understand the English language on the paper, right? We just want to make sure that it's worded correctly. Okay. So here it says, what must be true about angle 7 and angle 3 for them to be parallel? Okay. So we're looking at those. And then look, I even have the answer for you. For line L to be parallel to line M, angle 7 and angle 3 must be what? What must they be? No, I'm telling you the lines. For the lines to be parallel, what do we know about the angles? They must be what? They must be congruent. I know that these have to be congruent. They have to be congruent angles by the converse of what type of angles? So they have to be congruent. You can just use the symbol. And then our answer is what? By the converse of kind of angles are those? Corresponding angles. So, there we go. Okay, let me ask you a question. How many of you have the sentence stem on your paper? Okay, I'm going to have you copy down the sentence stem here in just a minute, okay?